Okay, section 6.5, we are going to talk about two more types of parallelograms. What's the special types of parallelogram? Actually, we only talked about one special type of parallelogram. We've talked about a normal everyday parallelogram, and then we talked about one type of special one. What was that one special parallelogram we just finished talking about? We just went over the homework on that. A rectangle, right. Okay, we talked about a rectangle. I believe that's it, right? That was the only special one that we talked about. Today we're going to talk about, let me put the picture up here first. I have one already pre-drawn. Let me copy this and paste it right here. Make it a little bit bigger. This is another special type of parallelogram that we have. What do you think is different about this parallelogram than just an ordinary, everyday, run-of-the-mill parallelogram? What does it look like could possibly be true about this? What's special about this? It's definitely not a rectangle, is it? Somebody in the last class said, oh, this is a square. Does that look like a square to you? Does it? Nah, it doesn't look like a square to me. All right, it does have four sides, but it does have one thing that's closely related to a square. What do you think might be true about this that's closely related to a square? All the sides are equal. Very good. Okay, all the sides are equal. Look. This side equals this side equals this side equals this side. All right? So right there, I've got a four-sided figure with all four sides equal to each other. Does that necessarily make it a square? No, we're going to talk about a square in a few minutes here. All right, but this is not a square. This, if you have a quadrilateral with four equal sides, all four sides are exactly the same. Watch this word. You might have heard about this word. I doubt that you've probably talked much about it at all. It's called a rhombus. Anybody heard of a rhombus before? Okay. They probably don't deal with it too much in the lower grades. They might mention it, but they probably don't tell you a whole lot about it. But this is a rhombus. Okay, and what is a rhombus? It's basically a quadrilateral. I'll tell you what, let's write that down. You guys are writing, correct? It's a quadrilateral with four equal or congruent sides. Now, I said it's a quadrilateral. Well, it is. It's four-sided. But since all four sides are equal to each other, guess what else I could say about this quadrilateral, besides being a rhombus? It's a what? Well, it's equilateral. That's true. It is equilateral. But one of the words that we've talked about before as far as a four-sided figure. It's a parallelogram, isn't it? How do you know this is a parallelogram? I didn't tell you that any of the sides were equal or parallel to each other, did I? But watch this. Remember what's true about a parallelogram? If I can show that both pairs of sides are equal to each other, then it's a parallelogram. Is that true about this thing? Yeah, because this pair of opposite sides are equal and this pair of opposite sides are equal. So guess what? It's got to be a parallelogram. Would you agree? So that means everything that's true about a parallelogram that we knew is true on this thing, right? The opposite sides are equal. The opposite sides are parallel. Even though I didn't say anything about this thing being parallel, I could tell you, since I know now that it's a parallelogram, that these two sides are parallel and these two sides are parallel to each other. All right? What else is true about a parallelogram? The diagonals. What's true about the diagonals? They bisect each other. That's right. So that's true about this thing. What about the angles? What about the opposite angles? Since this is a parallelogram, what's true about these two opposite angles? They got to be equal to each other, right? All the stuff that we learned about parallelograms before holds true with this thing right here. Anthony, you getting all this? It'd be better if you looked up here. All right, so this is a parallelogram. Okay, so a rhombus is a special type of a parallelogram. Okay, it's just a parallelogram with four equal sides. That's all it is. We good? Now let's see what's a little bit more different than just saying we got four equal sides. Let's draw the diagonal. So go ahead and draw that on your paper. You should be taking notes. You should be drawing all this stuff. Try your best. Now I know I've got this fancy program, but try your best to make those four sides equal to each other. All right, on this rhombus. Now let's take a look at the two lines that I just drew right here. Let's label it A, B, C, D. Now we don't have like a special symbol or anything for rhombus. We would just say it's rhombus A, B, C, D. We just use the word. Okay, no shortcuts or anything. Short enough word. So we just say it's rhombus A, B, C, D. All right, no special symbols. There's a couple things. There's two things. I'll even label it 1 and 2. There's two things that's special about this rhombus and these diagonals? Well, first of all, look at the diagonals. They bisect each other, but we already knew that, didn't we? We already knew they bisected each other because it was a parallelogram. But they do something else that doesn't necessarily happen with every other parallelogram. Look at how they meet right here at this point of intersection. Does that angle look anything special to you? It doesn't? What is it? It's a right angle. Yeah, absolutely. That right there is a right angle. Before, when you had a regular, normal, everyday parallelogram, it didn't meet at a right angle. Okay, they only meet at right angles if this thing is a rhombus. What does it mean to be a rhombus? All four sides are equal. Okay, so if all four sides are equal, the diagonals will meet at a right angle. What would I say with those two lines? Give me a good geometry word. If two lines meet at a right angle, we say those two lines are what? Perpendicular. Good. Okay, so let's write that. So we're going to say this. Write this down. You should be putting this in your notes. Should be putting this in your notes. Come on. Don't make me beg you. Everybody should be doing this. You writing this down? Where's your pencil? Okay, very good. So the diagonals of a rhombus are what? Perpendicular. So that should be written down in your notes. Okay, so whenever you have a rhombus, the diagonals will form a right angle right there. And that's very helpful to find some other angles, knowing that that's a right angle. All right, so that's true about a rhombus, and it's not true about all the other parallelograms we've talked about. A rectangle, is that true about a rectangle? No. We know the diagonals are equal to each other, but on a regular rectangle, they do not, they are not perpendicular. They don't meet at a right angle. But when all four sides are equal to each other, they will meet at a right angle right here. Okay? If I said that enough, I think I have. Okay? Try to repeat things like 4 or 5 times so that one of those times, hopefully, it sticks. Let's look at the second thing. I said there was 2 things that was true about this. Let's go different color this time. Look at this diagonal again, and look how it cuts this angle. What do you think? Just kind of looking at it, what do you think might be true about this diagonal and this whole big angle? What do you think that does to that big angle right there? It bisects it, exactly right. And it does. It does bisect it. And there are reasons for it, and there are proofs and things like that, but we're not going to go through that. If this was honors, maybe I might do that a little bit more. But for you guys, I just want you to see it. I just want you to understand what's happening here. So this actually bisects that angle. Okay? Everybody see that? And remember, the opposite angles are equal to each other because it's a parallelogram. So if these 2 angles are equal to each other, these 2 angles are equal to each other. Actually, all 4 of these blue ones right there are equal to each other, right? Because this big angle B and this big angle D are the same because they're opposite angles. And they're both being bisected, so they're both being split in half. So they're all 4 of those are the same exact angles. So let's do this. So we can also now say that the diagonals of a rhombus, this only happens with a rhombus, okay? Only if you have a figure that has all 4 sides equal to each other. The diagonals of a rhombus bisect, we'll just say the opposite angles. The opposite angles. All right? So that's what's happening here. Those 2 diagonals, they bisect these 2 angles, and of course, this and this angle would be equal, and this angle down here and this one right here would be equal. That's really important because they're going to give you a picture like this. They're going to chuck in an angle, for instance. Let's do a quick little example right here. Let's say that that was 30 degrees. Just knowing that one little angle right here, and knowing that this is a rhombus, I can actually find all 4 of those blue angles. So let's go do it. If this is 30, what's this angle right here without doing any math at all? It's 30 because it bisects that angle. Let's come up here. I didn't tell you anything about this angle up here, but what did we say? These 2 are equal to these 2. So how much are these 2? 30 and 30. What about these? Are these also 30 and 30?
No. Yes.
Come on, that's an obtuse angle, isn't it? Is there any way that's 30 and 30 to make that obtuse angle? No, there's no way. So look what we have. This is 30, right? You could look at it a couple ways. Here's how I would look at it. Do you see this right triangle right here? Okay. You know that's a right triangle because you know the diagonals are perpendicular. So you know that's a right angle. That's 30. What does this have to be? It's got to be 60, right? You see that? That has to be 60 degrees. Why does that have to be 60? Well, 60 and 30 is 90, plus 90 is what? 180, right? And you got 180 degrees right there. See that? So you got to think a little bit about the relationship. Don't just say, well, everything's 30. No, you can't do that. You got to think a little bit, all right? Watch what you say, because there's no way that could be 30 and 30, because look, that whole thing is an obtuse angle. There's no way that whole thing could be 60, right? But if this is 60, what's this one? That's 60. Now, could the whole angle be 120? Absolutely, sure, that could be 120. What about down here? What are these going to be? 60 and 60 down here, okay? Make sense? It's not so hard, is it? No. Okay, so that's a rhombus, and that's the stuff that's true about a rhombus. You know what they're going to do here, though, don't you? They're going to, they're going to say this angle is like 3x plus 2, and I don't know, this angle down here might be 5x minus 1 or something like that. Agreed? And then they'll ask you to find some relationship between them or something, okay? Get rid of all that right there. All right, so there you go. Let's move to the next one. So that was, oh, by the way, I almost forgot this. Oops. We said this was a rhombus. Well, that's one rhombus. Okay, so that would be singular. There is a different word for the plural. It's not rhombuses. Okay, it's rhombi. Very good. It's rhombi. Okay, that, I'll put a PL next to it in parentheses. That's PL for plural. So if I had 2, 3, 4, what? Rhombi, right? I have one rhombus and I have 2 rhombi. So if you look at the title of the lesson says rhombi and squares. The reason they say rhombi is because they're using the plural version of that. All right? Just so when I say that word, you're like, what's he talking about? I know a rhombus, don't know what a rhombi is. It's just a plural. All right, here's the second thing we're going to do. And we've actually mentioned this already today. What do you think this could possibly be? It's a square, right? You learn these when you're a little kid, before you could talk. Okay, probably you learned about your shapes. If you watch Sesame Street at all, you probably learned what a circle is, and what a triangle is, and what a square is, what a rectangle is. All right, so from a little child, you had some kind of recognition of what a square was. But you had no idea how involved a square actually is until probably today. So if this is going to be a square, let's just just with our own knowledge before we actually walked in the room, okay, learning from Sesame Street, learning from your parents, learning from elementary school, middle school, and everything else up to this point, what do you think you can say about a square? Let's talk about the sides of a square first of all. They're equal to each other, right? Isn't that what you know about a square? So I could say this side is equal to this one, is equal to this one, is equal to this one. Okay, that is true about a square. Well, what does that make that thing then? If all 4 sides are equal, that square must also be a what? Yeah, a parallelogram, but we just talked about it. What? A rhombus, right? Okay. A square is also a rhombus. How about that? What else do you think we know about a square? Is that the only thing we know about a square, is just all 4 sides are the same? The angles are all the same as well, okay? And if they're all the same, what must they be? It must be right angles, that's right. So a square has all 4 right angles. What's another figure that we've talked about just a couple days ago that has all 4 right angles? A rectangle, right? So guess what a square is? A square, I'll branch it out like this. A square is actually 2 things. What is it? It's a rhombus, and it's also what else? A rectangle. Okay, so square is actually everything. And above all this, what is it? Somebody said before, it's a parallelogram. All right, so here's kind of like the hierarchy of these different figures. Start off with a parallelogram, and then a special type of parallelogram is a square. And guess what a square is? A square is actually a rhombus and a rectangle. So a square is a bunch of stuff. Let's think of all the fancy math words that we can muster, okay? So a square is a quadrilateral. Why is it a quadrilateral? Because it has what? 4 sides, right? That alone just makes it a quadrilateral. It's a parallelogram because the opposite sides are equal to each other, right? And the opposite angles are equal to each other, and so on and so on. It's also a rhombus. Hello.
Is Bria Rogers in the class?
Yes, she is.
Can you send her down for an early dismissal?
I will. So a parallelogram is a square is a rhombus, and a square is also a rectangle. So all the stuff that's true about all these other things have got to be true about a square. Okay? Here's a worksheet for you. You're welcome. Okay, so let's go through some stuff then that we know. Let's go. Just make it. It seems like I use the same colors all the time. I haven't used green yet, have I? Let's use green. So watch this. The diagonals always play a good part in this, don't they? So let's talk about this. Well, a square is every one of those things, right? So what did we just learn about the diagonals of a rhombus? What are they? Perpendicular, right? So they're got to be perpendicular on a square as well. Why? Because a square is a rhombus. So everything that's true about a rhombus is true about a square. Everything that's true about a rectangle is true about a square. What did we know about the diagonals of a rectangle? The lengths of the diagonals. What are they? They're equal to each other, right? Okay, they're equal to each other. That means AC equals BD, doesn't it? And they also bisect each other because it's a parallelogram. So look, this segment right here, and this one, and this one, all 4 of those things are equal to each other. There's all kinds of stuff we could say. Well, remember, a square is also a rhombus, so guess what it does up here? It bisects this. In fact, I didn't give you any numbers whatsoever, did I? I didn't tell you any angles except for the fact that you know that was a right angle. Tell me what that little angle is right there, angle DBC. This little angle right there. It's 45. How'd you get 45? That's right, you just went 90 divided by 2, didn't you? Because you bisected that 90-degree angle. Everybody see that? So if that's 45, guess what? Every single one of these bisected angles right here is going to be 45 degrees. They're all equal. 45, 45, 45, 45, and so on down here. There's tons of stuff you know about this thing now. You know all the angles inside of here are 90 degrees, don't you? What else? You know the opposite sides are parallel. You know opposite angles are equal. You know just everything you knew about a parallelogram, everything you knew about a rhombus, and everything you knew about a rectangle holds true with a square. So a square is a pretty complicated little figure, isn't it? All right. Ever since you're a little kid, you probably thought, oh, it's a little simple little, figure. But really, there's a lot of stuff that you know about a square. It's amazing. You don't look as amazed as I do. You're not as amazed as I am. I'm pretty amazed. It's just a simple little figure. There's so much to know about that little tiny figure right there that looks just as simple as could be. Wait till we start talking about circles. You'll really be amazed about circles because there's a ton of stuff that you would have never even dreamed about. They'll probably turn into your nightmare by the time you get to it. I don't know. Hopefully not. But there's a ton of stuff. Just triangles. We're going to eventually, my honors class right now is on a chapter on just right triangles. The whole entire chapter just on a right triangle. A whole chapter on it. I mean, how could people even think about enough stuff to put in just for one right triangle? It's amazing. But what we do, all right? So there you go. All right, I think I've given you enough information. So that is, it's not page, it's section 6.5. I'm going to give you a worksheet here, and you just do the front and the back. And there's some you skip. Remember all the ones that say proof or coordinate geometry, you can skip those. You can figure those out yourself. I'll pass them out. So make sure that's done for tomorrow.